Awesome, man. Okay, first question after the intro, just to set the vibe here, is about software supply chain security. There are tons of acronyms out there that I'd love the audience to learn because we're pretty eclectic here. Could you help us explain some concepts like SAST, DAST, IAST, SEA, ASPM, I'm not done, and RASP?
Yeah, there's no shortage, isn't there,
No.
of acronyms. In fact, we're talking about supply chain and CI today, and we don't really have an acronym for that one yet. So maybe we can make one up. We can riff one while we're here doing the podcast. But
why not?
Yeah, you're going back to my application security roots with a lot of those, because the ASTs, the application security testing tools. I just mentioned one that I used to be heavily involved with, which was SAST. So that's just a tool that scans the code you write to look for potential weaknesses, usually measured in common weakness enumeration, so CWEs. But that's, I feel, getting a little less important these days as more people are using open source, which is what we're going to get into, methods of attack through open source packages and dependencies. Mm-hmm. And that's what SCA, or software composition, is looking for. And that I think is probably one of the most important tools you can have in your arsenal in terms of supply chain security these days. Mm-hmm. And then some of the older ones, DAST is just dynamic application security testing, or forms of automated pen testing like OWASP ZAP. IAST, that's a dark art.
Wow.
Interactive application security testing is where you plug directly into the runtime. So like either the Java runtime or Node, and you can actually use that connection to watch every call that's happening within that runtime. Dope. And from there see that there's a potential attack vector moving through your code base and getting access to some form of sync like a database. So it's very, very difficult to achieve, but amazingly cool if you can make it work. But I don't see a great adoption of ASPM. I don't know if that's marketing or real. That's application security posture management. And there's a lot of startups claiming they do kind of like a holistic perspective all the way from monitoring applications and runtime back to the code that created them, and even the infrastructure as code that provisioned where the application is running. They're looking at the holistic perspective to try and allow you to prioritize the sea of findings that most application security tools create, so that you're actually looking at ones that matter.
Nice.
And then RASP is a version of IAST that monitors runtime, as opposed to a little bit like a WAF. I sometimes confused with a web application firewall.
Really?
And then, there's a little bit of, there's a real Venn diagram of crossover between those two.
Interesting.
And what else did you mention? Did you say?
I said SAST, DAST, IAST, SCA, ASPM, RASP. And there was, I still have one for you, man, if you want to explain it. What is fuzz scanning?
Oh, there's a great example of that. Fuzzing is where you've got, your expected inputs. So say if you're doing integration testing or even unit testing, right? Mm-hmm. You're going to pass into that function or that application or that API examples of good input, typically, to see that you get the responses you want. Fuzzing is the automated generation of bad input at scale.
Wow.
So that you can send all sorts of garbage into your application and then see if it survives, see if its input sanitization can handle the results. And the most famous example of fuzz testing or fuzz scanning being successful was Heartbleed. If you remember, one of the most famous logoed vulnerabilities of all time, that melting heart logo, that was found with fuzz scanning OpenSSL. And it found that if you sent the heartbeat to OpenSSL, but you told it that, I sent you 5 characters, but in the packet you said I sent you 5,000 characters. Oh. It was trusting the heartbeat size, and it would then send you back, an echo of the heartbeat. But instead of sending you 5 characters, it would send you the entire contents of its memory.
Wow.
And that was how that vulnerability played out. And that was found using fuzz testing by sending malicious, screwed up inputs. So that's a great example of where fuzz testing is very effective.
That's sick, man. I'm actually discovering it. So fuzz scan, it's like the wrong way of doing QA, but it will still ensure that your application is actually resilient, right?
It's exactly about resiliency. Yeah. I had a friend of mine who's an expert in fuzz testing, and he fuzz tests every piece of electronics he buys. And he once bought a new TV and broke it within an hour and had to take it back.
Wow.
Yeah.
Okay. I mean, he was just playing, but he didn't do it just so he can have a better TV.
No. He created a problem for himself. He didn't want to do that.
Okay. Oh, poor dude. Right. Interesting. Very interesting.